Hello everyone, this is Professor Nassar, and I want to welcome you back to the course. Today what I want to be talking about is sort of a mini lecture within Chapter 8 on plate tectonics, where we talk about faults. This is something that is explained a little bit in the slides, and you can find elsewhere online very easily, and it's something I would normally do with you in class, but instead, due to the circumstances, I'm doing this online. And what I will also do, just to make sure you have some facility in being able to identify and draw different kinds of faults, is there will be an exercise that will go along with this that will be sort of a class assignment that you can do on your own time and then submit for credit. So the way faults work is something like this. What you want to do is, as you're watching this video, is you want to pull out a piece of paper, something like this, and something to write with or write on, and sort of follow along with me, or sort of make your own version of this. We're going to draw a little bit. So when geologists talk about faults, what we're talking about is basically a block of the earth that looks something like this. So the first thing you want to do is basically draw a rectangle. And then just to give yourself some scale, if you want to draw a stick figure, that's you standing on top there. This is a block of earth, and right now there's no fault in the earth. It's basically just a block of dirt or rock. What's going to happen here is we're going to draw a line from somewhere at the top to somewhere at the bottom. And you want the line to be at an angle. You want it to look something like this. Or it could go the other way. What you don't want to do is you don't want to draw a block where the line is perfectly vertical, and you don't want the line to be perfectly horizontal. This is the fault line. And what this indicates when you draw something like this to a geologist is that there's going to be movement between this block and that block. We could call this block A, or you could call this, let's call this block A and block B. And there's a fault line, meaning that block A or B, one is going to move relative to the other. So how a fault occurs is basically there has to be some break in the earth. So this is sometimes known as a joint or some sort of seam or break, but there is a movement along this plane. One side of this block is going to slide up or down relative to the other. Now, in order to talk about which side is moving relative to the other, there is a convention that geologists use when talking about one block versus the other, in this case block A versus block B. And the convention is this. Let's say you drew your fault looking like this. This is the fault line again here, and the idea is that if you start, let's say, go to the middle of your fault right there, and go up. Which block are you in? If you start at the dot here and you go up, you are in this block, block A. So this block, because you go up from the fault, is called the hanging wall. And we can abbreviate that as HW. The block that's below the line of the fault, if you basically start anywhere along this fault line and move down, that's called the footwall. And so by creating these two terms, we establish a convention whereby we can discuss which block is moving relative to the other. The hanging wall is moving up or down relative to the footwall. How about on this block? Which is the hanging wall and which is the footwall? So is the hanging wall, is it A or B? Again, to find out, you go to the line where the fault is, and the hanging wall will be above the fault line, so you go up. In this case, the hanging wall is B, which means that the footwall then must be block A. You notice that it's the reverse of what we had here, where the hanging wall was A and the footwall was B. Okay, next we have to move the blocks, and so this is how we discuss one way to move it. Let's go back to this block here, and let's now move the block so that the blocks have moved something like this. Block B, as you can see, has slid down relative to block A. And again, now let's put in the names of the walls. So again, block B is the hanging wall, and block A is the footwall. How we describe the direction of movement is basically we draw two arrows on either side of the fault line, except in this case we don't draw the arrow like this, like how everyone in the world would simply draw an arrow. Instead, we draw half the arrow like this to indicate direction among the direction of motion on one block, and then the other block, the arrow goes in the other direction like this. So we draw two arrows, but only sort of half of each arrow going in opposite directions to indicate the direction of motion along each block. Each block gets one of these arrows. So in this case, since block B slid down, we draw one arrow like this, and since block A moved up relative to B, we draw the other arrow like that. In this case, block B slid down relative to A. The hanging wall moved down relative to the footwall. This kind of fault motion is called a normal fault. You could, of course, have had the opposite happen. Block B, the hanging wall, moves up relative to the footwall. That would look something like this. In which case we draw the arrows like so. This type of fault is called a reverse fault. Where the hanging wall moves up or slides up relative to the footwall. There is a special type of reverse fault that's known as a thrust fault. And what happens in this case is the thrust fault is a reverse fault where the fault angle is less than 30 degrees. It's sometimes called a shallow angle reverse fault. And it looks something like this. The fault angle, by the way, is this angle here. This would be the fault angle, and this would be the fault angle. These two angles are the same angle due to way back when you took high school geometry. These two angles are the same sort of side angle side type idea. And so what we're measuring is this angle. If it's less than 30 degrees, that's a thrust fault. If it's 30 degrees or basically more than 30 degrees, we call it a reverse fault. So a thrust fault would look something like this. Draw your block. And instead of making sort of a more steep line, you make a very shallow angled fault line, looking something like that, for example. So again, which one is your hanging wall and which one is your footwall? Again, you start, this is the fault line. There's going to be slippage or movement along that fault line. You go down, and this would be the footwall. You go up from that line. This is the hanging wall. The hanging wall is going to slide up relative to the footwall, and that angle, the fault angle here, is less than 30 degrees. So as a result, we call this a thrust fault, a shallow angle reverse fault. These types of faults are sometimes known as dip-slip faults. Normal fault and reverse faults and thrust faults. Because the angle of the fault has a dip to it and one side sort of slips down relative to the other. There is, however, a second category of fault that is called a strike-slip fault, and it looks something like this. In this case, the plates are sliding past one another along the fault line horizontally. In these cases, you had the fault moving up or down relative to the other. But what if the fault basically moved in or out of the field of view, out of the page at you? There wasn't an up-down motion, but rather a side-to-side. That's what we call strike-slip faults. And so when we try to draw these, there are two kinds, and when we try to draw them, the perspective changes. Instead of drawing a side view of the fault like we were doing here, in this case what we want to do is draw the fault, or is draw the field of view so that you're looking from above, like a bird's eye view. So let's say you had a, this is your block. And let's say there's a road here. And let's say, so now we're looking at this from above, like you're a bird or a helicopter or something looking from or a drone looking from above. And let's say there is a fault that comes through here and is going to sort of split this road in two. So this is the before and this is the after picture. Here is the bottom half of the road, and here is the top half. And here is the fault. Okay, so this is a strike-slip fault, but there are two kinds, and the question is, which kind is this? So let's say you were walking along this street here, and suddenly, of course, you saw that the street has moved away. The rest of the street has moved away. If you were standing here and you wanted to follow, like, where is the street? Would you look to the right or would you look to the left? Obviously, you would look to the right. And so we would call this a right lateral strike-slip fault. You may think, but Professor Nassar, what if the situation were, what if you were coming at that street from the other side, like you were here? You happen to be walking this way. Wouldn't it switch? Well, actually, no. If you look at it, because you flip the perspective, it's still the same thing. You walk up the street here, and where has the street gone? Do you look to the right or do you look to the left? Well, obviously you look to the right, or you would walk to the right to continue walking along that street. So this is a right lateral strike-slip fault, no matter which way you approach that perspective. If the block had moved to the left, of course, then it would be a left lateral strike-slip fault. It would look something like this. Like so. And so we would call this a left lateral strike-slip fault. Again, with faults, we like to indicate direction of motion. So in a strike-slip fault, again, it would look like this, where this plate is moving in this direction, and the plate below is moving in this direction. The reverse for a right lateral, this plate, the plate above the fault line is moving to the right. The plate here is moving in the opposite direction. Okay, this comes into play when we start talking about in sort of larger geographical real-world context. The most popular one probably is something like the San Andreas Fault in California. See if I can pull it up or show you a little picture of it. Let me get a new piece of paper. I'm just getting another piece of paper. Okay, so how do we apply faults to real life, especially something like a strike-slip fault? Let's say you were to draw the state of California. California looks something like this. And there are two major cities in California. The one up here is San Francisco. And the one down here, well, okay, more than two. There's San Diego too, but we're going to just talk about these two for the time being. The one down here, of course, is Los Angeles. All right, as most of you are probably aware, there's a big fault that runs through most of California called the San Andreas Fault. And it looks something like this. Coming down from California is a little peninsula called the Baja Peninsula or Baja California. This is basically Mexico down here. And the San Andreas Fault essentially runs through all of this, sort of comes between the Baja Peninsula and Mexico, comes up here, and sort of divides California something like this. This part, where the fault is actually on land, this is the Gulf of California, and this is the Pacific Ocean. This part, where the fault is actually on land, this is the San Andreas Fault. Now, the interesting thing about this, and why I bring this up, is because if you notice, San Francisco is on one side of that fault, and Los Angeles is on the other side of that fault. Wouldn't you know it, San Francisco is on one tectonic plate, Los Angeles is actually on a different tectonic plate. San Francisco is on the North American plate, and Los Angeles is not. This type of fault is a strike-slip fault. And the direction of motion is something like this. San Francisco is basically the plate that San Francisco is on, the North American plate, is moving south, and the Los Angeles plate, the plate that Los Angeles is on, is moving gradually to the north. And so at some point in, whoa, there goes, I have this propped up on a lamp. And that lamp is, it's an old lamp and not necessarily stable. And so the idea is that San Francisco is gradually moving to the south, Los Angeles is gradually moving to the north. At some point in a couple of 10, 20, 30 million years or so, San Francisco and Los Angeles are going to be neighbors. My question to you is this a right lateral or left lateral strike slip fault? So again, the way to determine this is if you're standing on, let's say, the Los Angeles plate, which way is the plate on the other side of you moving, to the right or to the left? Or if you want to reverse it. If you're standing on the San Francisco plate, which plate is the plate that Los Angeles is on moving, to the right or to the left? Well, as you can see by the arrows, it's moving to the right. So this would be considered a right lateral strike slip fault. All right, that's it for today, for this sort of mini lecture. Hope you enjoyed it. There will be several more to come, and like I said, there will be an exercise coming up soon on Blackboard if it's not there already, where I ask you to sort of make something like this on your own. Okay, I'll see you soon. This is Professor Nassar signing out.